We are looking at problem 10.5, the internal rate of return for our Powerball deal in question 4. So we know that with a discount rate in problem 4 of 8%, and once again, think of this discount rate as the cost of capital. We could have gotten 8% investing our 20 million somewhere else, so we want to know what so that's actually the cost of capital for this $20,000 initial investment. Anyway, so we want to understand that because the net present value is positive, and it's positive by a fairly good amount, over $1 million, then our internal rate of return has to be higher than the discount rate or the cost of capital. It has to be higher than 8%. So that we know. We're going to jump back over here and figure out exactly what it is. Well, actually, let me come back here and let me just copy these cash flows out so we don't type them in individually. This will be quicker, right? Okay, so we copy this and then come back to our internal rate of return problem and put our cash flows in. And we see that we do have a higher internal rate of return than the discount rate. Our internal rate of return is actually 8.78%, and this is rounded off, and I'll show you that in a minute. But what this is really telling us is with this discount, with this rate of return, our net present value is 0. So our internal rate of return is the rate of return that would make our net present value 0. And so this formula that I have right here is just simply the Excel formula for the internal rate of return. If you look up here, it's just IRR, and then in parentheses the cells that have our negative and positive cash flows, C10 through C35. And we put that right there, and that's going to give us our internal rate of return, or the rate of return that returns that gives us a break-even deal. So it is over 8%, and we can show that. Oh, by the way, let me just show you this. In order for this to actually be 0, it had to be. I'm going the wrong way. It had to be this number, right? This is what actually gets us to 0. Now, what's fun about this is, let me just bring that back to normal. Whoops, wrong way. Let me bring that back to normal. 8.6, because that's all you have to have for your answer. 8.78 right here, and you put that right there. Now, if we go back to our problem 4, and let's just play around with this. So we know that what this should tell us is, with any discount rate below 8.78%, we should have a positive net present value. And we can show that. We can put in 8.6. And we're still not 80, well, not that. That's not going to work. 8.6, right? Okay. And we're still positive at 8.7. We're still positive, right? At 8.78, we're still positive. 8.78, right? We're still positive barely, because if we, once again, if we go back to our IRR problem, this isn't really 8.78, this is 8.78 and change, right? So this is what we would have to put in to get exactly 0. So if it's 8.780000, which is what we actually put in over here manually, we're still just a bit positive. Now, anything over that, say let's try putting in 8.8, then we're negative, right? And remember, the parentheses means we're negative. So you can see that the internal rate of return tells us what a discount rate we would have to have in order to get a positive or either a 0 or higher net present value. Okay, so that is problem 10.5, internal rate of return.